Welcome to this explainer. Today, we're cutting straight through all that marketing fluff to help you choose the exact right total station for your site in 2026. Listen, if you're a surveyor, a site engineer, or a general contractor, you already know the deal. The stakes out there are incredibly high, and tolerances are only getting tighter. So we're going to take a highly practical, expert look at how to actually navigate today's hardware landscape.
Let's kick things off by busting a massive myth right out of the gate. Throwing your entire equipment budget at some premium top-tier instrument absolutely does not guarantee you better results. In fact, if it's the wrong tool for your specific everyday workflow, it's literally going to slow you down. The absolute best total station out there is simply the one that perfectly matches your site, your crew, and your tasks, period.
So, here's our site plan for today. We'll briefly define the baseline tech, break down the big three categories of instruments, and figure out how to match the tool to the task. After that, we'll decode those confusing accuracy ratings, get into some very practical buying advice, and wrap it all up with a final verdict.
All right, first up, let's make sure we're all starting from the exact same control point.
You know, the tech has come incredibly far. A total station is no longer just a basic angle and distance tool. In 2026, it's basically the heartbeat of modern construction layout. These instruments are combining precision optics with robotic tracking, GNSS integration, and some seriously complex BIM workflows. They're the bridge between the perfectly drafted design in the office and the messy, physical reality out in the mud.
Moving on, let's look at how the technology actually breaks down today into three distinct tiers of operation.
First, we've got the classic showdown, manual versus robotic. Now, manual stations are still incredibly cost-effective. They're rock-solid for smaller works, but they do require a two-person crew. On the flip side, robotic stations, think the Topcon GT or the Sokia iX series, are total game-changers. You get one-person operation, automatic target tracking, and vastly faster stakeout workflows. If you're a site engineer needing serious daily productivity, robotics are the way to go. And then we have the heavy hitters, scanning total stations. These are premium, top-shelf instruments like the Tremble SX12 or the Leica MS60. They don't just shoot single points, they combine that precise point measurement with incredibly dense 3D spatial data capture. Honestly, you only really need to invest in this tier when missing information is expensive. We're talking complex BIM verification, clash detection, or doing highly detailed facade surveys.
Okay, so how do we actually match the hardware in your box to the reality of your job site? It all comes down to aligning your tolerances with the work. Think about it. Basic setting out and bulk earthworks just don't require crazy high precision. A 5-second instrument is going to be absolutely perfect for that. But as soon as you transition to tasks like laying out building grids or dropping structural anchor bolts, your tolerance tightens right up to 1 or 2 seconds, and you really want a robotic unit for that. Over-speccing your hardware is just as bad and just as inefficient as under-speccing it.
Now, speaking of tolerances, let's decode those accuracy requirements because they can get a bit confusing.
Basically, a 5-second instrument is going to be your go-to for laying out curbs, footways, and general earthworks profiles. Moving up, a 2 to 3 second instrument is your daily workhorse for roadworks, drainage, and just general site engineering. But, and this is a big but, if you are doing any kind of structural monitoring, laying out high-value steel frames, or transferring complex building grids, you absolutely must be working in that tight 1 to 2 second bracket. No exceptions.
To put this into perspective with some real-world numbers, let's talk about how angular accuracy affects lateral error over distance. If you use a 1-second instrument at a distance of 200 meters, you're looking at a lateral error of just about plus or minus 1 millimeter. Pretty great. But if you take a 5-second instrument and shoot that exact same 200-meter distance, you're going to get nearly 5 millimeters of error just from the angle alone. Distance really dictates your accuracy requirements here.
But hey, I've got to give you the veteran site engineer truth right now. Buying a super expensive, highly calibrated 1-second instrument is a complete and utter waste of your budget if you're just going to throw it on a wobbly tripod or use sloppy control methods. Seriously, centering error, prism constants, your observation methodology, all of that matters just as much. Your fancy new instrument simply cannot outperform bad field procedures.
All right, let's pivot to some practical buying advice and see what makes sense for your business. The market right now is packed with incredible tools from some very established brands. Leica is phenomenal when it comes to construction layout software with their Icon system, and the Pro TS16 is a beast. Trimble really shines if you want seamless GNSS and software ecosystem integration. Topcon is incredibly robust, perfect for heavy civil crews. So Kia gives you a really practical robotic alternative without that massive premium price tag. And GMX, they deliver serious value for general contractors. Ultimately, your choice needs to be driven by ecosystem compatibility.
So what should you actually buy? Well, if you're a small contractor doing occasional layout, prioritize a durable, value-driven manual station. But if you're a dedicated site engineer out there doing heavy layout every single day, investing in a robotic unit will quite literally pay for itself in labor savings within a few months. Survey companies, you need those 1 to 2 second integrated robotics. And BIM professionals are the ones who truly need to pony up for those high-end scanning units.
We've covered the tech, the tasks, and the tolerances. Let's lock in our final verdict.
At the end of the day, there is literally no single best total station in the world. The best investment you can make is the instrument that flawlessly integrates with your specific office software, whether you're running CAD, BIM, or Land XML. It's the instrument backed by solid, easily accessible local service and calibration support for when you inevitably drop it in the mud. Prioritize long-term reliability and match the tool to the task rather than just buying a flashy brand name.
I'm going to leave you with one final, kind of provocative thought to chew on before you sign that purchase order. Having the world's most capable, most expensive total station means absolutely nothing if your field procedures, your control network, and your tripods aren't up to that exact same standard. Build your skills, dial in those workflows, and then, and only then, buy the tool that matches them. Thanks so much for joining me on this explainer. Catch you next time.